She has a diverse academic and professional experience background spanning more than 15 years and has served in many engineering colleges across the length and breadth of the country in various capacities. She has been the part of organizing committee of various international conferences, convener of many FDPs and STTPs, as well as resource person for many AICT ATAL sponsored FDPs. Her research interests include data science and analytics and digital image processing. She has published many papers in reputed journals and conferences and has many book chapters to her credit. She is a senior IEEE member and fellow of IET. She served on the editorial and review board of multitude of journals related to computer science. She has 2 patents and one copyright to her credit. With this, I request you, ma'am, to please start the session. Over to you, ma'am.
Thank you so much. Thank you, Ayushri, for the introduction, and thank you to Dr. Chetan for this opportunity. You already have had the first session on data science, so I'm just assuming that some basic background or knowledge about data science you would have already acquired. But my agenda for this particular session is to acquaintize or familiarize you with one very, very popular data mining tool, which is called as Weka. And I have been extensively using this tool for my own research purposes, and it's a wonderful tool, a lot to explore in that tool. But before we move on to that, I would like to briefly give you my take or my viewpoint on data science and what is my viewpoint on what data science is. So what I'll do is the first part of the session, I'll be just familiarizing you with what data science is, and then we start with a hands-on demo on Weka, where I will be taking certain agricultural data sets which are pertaining to soya bean, which are pertaining to the weather conditions and how we can predict various things out of it. So that is generally the agenda of my presentation. Just a minute while I share my screen. Yeah, just give me a minute. Yes, I hope the screen is visible.
Yes, ma'am, it's visible.
Yeah, okay, just a minute. I'll turn off my video. Yeah. So So good afternoon to everybody. They say any session prior to lunch is always boring, and after lunch it's extremely painful or torturous to keep your audiences engaged. But I have made my presentation in a manner that at least there will be something for everybody to look forward to or to see how we are going to use Weka as a tool for data science. And I would like to at the outset thank Anand Agricultural University and Dr. Chetan in specific to give me this opportunity to share my little knowledge, whatever I know about Weka, with all of you. And so what exactly has happened on internet a minute ago? Well, this is a very, very interesting slide, which I find very good to start my presentation with. Because when we talk about data science, what exactly is this data science? And what exactly are we going to do with this data science? To understand that, let us understand what's happening on the internet. Well, first of all, let me give you the first example. You and me are connected over the internet doing some kind of an exchange where we are exchanging some kind of audio, we are exchanging some kind of video. Also, some of you might be parallelly Google searching about my profile. Some of you might be opening the website of my college to see where do I teach, so on and so forth. So if I have to give the rundown of internet in 1 minute, it's around 375,000 app downloads, 67 voice first devices shipped, that is Google Play, Alexa, or other devices of the sort, 1.1 million swipes on Tinder. We have a lot of unmarried population, people ready to date, 973,000 logins on Facebook, $862,823 million spent on online shopping, 266,000 hours of Netflix watched, 4.3 million videos viewed on YouTube, and so on and so forth. And I would like to specifically mention this one, 3.7 million queries searched by Google in a minute. So this is what happened between the time that we started this session and the time that I have marked on this particular slide. So why am I telling you all this? What is the need? And let's see in 2019, what happened every minute of the day. What is the significance of this 2019? We all know. We all underwent a huge pandemic, which made everybody use digital platform in some way or the other. Those platforms which were earlier used only by people who were closely working in computer society or who were working with computers, they were the ones who used computers. But in 2019, almost every kid in every home who was going to school also used internet. And if you can see, YouTube users watch 4,500,000 videos every minute of the day. There were so many Skype calls because people wanted to get in touch with how are their loved ones doing, so on and so forth. Around, because pandemic hit, so the number of Uber rides that were taken reduced drastically. Number of Airbnb bookings, they reduced per minute, so on and so forth. So what am I trying to tell you through all this? And also, if you'll see over here, as far as 2014 to 2018 is concerned, so this has been the global internet growth of the population, as far as the internet is concerned. So from a 3.0 billion to 4.3 billion in just 2 years, just 4 years. So this is around 1.3% growth in just 4 years. That's a phenomenal growth. We are talking about data science tools, and a very, very good fact over here, which the Forbes magazine has put out, is that the amount of data we produce every day is truly mind-boggling. There are 2.5 quintillion bytes of data created each day at our current pace. So you can understand, when I say 2.5 quintillion bytes, it's huge. You know, bytes is 8 bits. And if it is 2.5 quintillion, quintillion means tons of bytes of data that we are creating at our own pace. But that pace is only accelerating. It's not coming down. And over the past 2 years alone, 90% of the data in the world was generated. You have to understand that. That means ever since humanity started, whatever data was there in the world, 90% of that data was generated in the last 2 years itself. And this is a report published by Forbes magazine, where they have done all their analysis and they have set their facts right. And there is, to corroborate the data, there's another report by Social Media Today, which again says the same thing, that over 2.5 quintillion bytes of data are created every single day. Now, when so much of data is being created, what do we do with this data? That's the biggest question that we kept on asking ourselves. That everybody is on internet, everybody is using the services. How do we utilize this data for doing something great, or for doing something good, or for providing customer experience, for providing customers, customers with the things that they require, so on and so forth. Sorry, my mistake. So you can see, before we get to know how much data is created every day and the future, it's worth getting acquainted with how data scales are changing in terms of units. So when I did my BTech, we used to have these floppy disks which had a capacity of megabytes. And the system that I bought for the first time, it had a RAM of 512 KB. And today, when we talk about the data that is being generated, or the data that is going to be generated in the future, we are talking about something called as yottabytes. So the data availability, or the way data is stored, or the way data is generated, it migrated from bytes to, from bits to bytes to kilobytes to megabytes, to data being generated in the tune of yottabytes today. Now, zettabytes is also obsolete. So when you say that I have a hard disk of terabytes, right? So with this as the understanding about data, now I will explain to you why data mining. So this term is very, very important. We all know that mining means extracting something useful from, let's say if it's a coal mine, there are a lot of things in that, but what I'm interested in is mining, the coal. Similarly, there's a diamond mine, there might be coal also there, but what I'm interested in a diamond mine is to mine diamonds, not coal, so on and so forth. Right. So because, as I told you, that the data has grown explosively from terabytes to petabytes to zettabytes to yottabytes. And why has it grown? Because data collection and data availability is very, very easy today. We all have a mobile phone in our hands, and we are every day browsing. Every second we are browsing the internet. So I'm logged in with my Google account. I'm using my Google account to download apps, to log into various apps, so on and so forth. I'm booking my tickets. I'm booking my, let's say, movie tickets, or I'm doing any kind of an interaction online. That's why the data is growing explosively. And major sources of abundant data are businesses, web, e-commerce, transactions, stocks. Science, remote sensing, which will be of interest specifically to you because you deal in agricultural domain. So a lot of remote sensing data about the soil quality of a given place, the kind of flora and fauna of a given place, so on and so forth, which is being generated by the satellites which are sent into space to collect data about the environment. Somebody said it very beautifully that we are drowning in data but starving for knowledge. There is it's like that age old saying that water, water everywhere, not a drop to drink. Similarly, data, data everywhere, but what is the knowledge that we gain out of data? So because of this humongous increase in the amount of data, what was felt or what was thought was that there has to be some way that this data can be used for extracting knowledge. And hence came into picture something called as data mining, which is automated analysis of massive data sets. Can I use this data to predict something? Can I use this data to classify something? Can I use this data to give some kind of a meaningful business decision to a client? So on and so forth. So that's why data mining began. And how did the sciences evolve? Well, before 1600, it was all empirical sciences. Okay, you were doing experiments, and that's what the science was. From 1600 to 1950, each empirical science branch started growing into a theoretical science. We started associating a theory or some kind of a justification to everything that's happening in nature. So we said that an apple falls down because of the gravity that pulls it down. So some theoretical science was in great vogue between 1600 to 1950s. It saw almost 300 years where theoretical science had its own forte, or theoretical science was the one which was holding the fort. From 1950s to 1990s was the era of computational sciences, because everybody got access to computers, everybody got access to internet. So there was a lot of emphasis given to computational sciences. And from 1990 to now, it is the era of data science, because of the flood of data from new scientific instruments and simulations, and the ability of the data to be available online, and the internet and computing grid that makes all these archives universally accessible. See, today I don't need to download a music on my mobile or on my pen drive. I have music on the go. I can just download an app called Wink or Savan Pro or something like that, and I have that data available with me. So, because of the universal availability of data, due to the growth in internet and due to the growth in computing power, data science has become the latest science which we are talking about, because of abundant availability of data, right? And this is how the database technology also evolved. So from 1960s, where we basically relied on traditional Excel sheets or something, where you would collect data, you would create a data, and then there would be a network database management system. 1970s, 80s, we moved on to relational database management systems. 1990, we moved on to data mining, and then in 2000, we are now at stream data management. Now everything is being streamed, whether it's a Netflix movie or it's the current lecture which is going on, everything is live streamed. So that's the kind of database technology that has evolved over a period of time. Now, what exactly is data science? So I've spoken so much. So what exactly is data science? I hope one thing is clear to you, that there is availability of data. Okay, abundance, availability of data. That's the whole thing that drives this data science. Now, once the data is abundantly available to us, we have acquired this data from multiple sources. We may acquire it from web services, from logs, from databases, from APIs, from online repositories. So just imagine you have a lot of data available with you. What do you do to this data? You first clean this data. Cleaning means what? Remove inconsistencies. If there's some misspelling, if there's some missing values, if there are duplicate values, you remove or you try to handle them somehow. And once you have cleaned the data, you transform it into the format that you want. You may want certain columns, you may not want certain columns, you may want the data to be in a specific format, so on and so forth. So the first step to any data science operation is data preparation. So you are preparing your data to be further analyzed or to be further subjected to certain models which are going to give you some kind of an information about it. Then you have exploratory data analysis, which defines and refines the selection of feature variables that will be used in the model development. So see, all the features which you are capturing while you are capturing the data may not be of use to you. For instance, I've collected the data of all, let's say, all men who are brand conscious. So in this kind of a data, the gender will not make too much of a difference, because I know that the data pertains to all men. So I might remove that attribute called as gender, because I know it's going to have a single value. Right. So like this is called as exploratory data analysis, where I define and refine the selection of feature variables that will be used in the model environment. And then you might apply some kind of an algorithm, some kind of machine learning, some kind of deep learning, some algorithm you might apply and create a data model. Okay, so let's understand. I had data. I will pre-process that data, meaning bringing that data into the form that I want. Then I will perform some kind of an algorithm on it, which will give me a model, right? And then this model can be used for visualization and communication. I might try to see, okay, what was the trend in the data? It might be used for any kind of visualization, and then I might deploy the model. And then I'll further start collecting the data and start moving in the same circle. So you'll see it's a vicious circle, which starts from collection of data, and then you may deploy the model which you have got, use it for some kind of an application, and then further, because of the more collection of data, it will keep going on in circles and circles. So this is how your data science works. Very simple 4-process step: collection of data, pre-processing of data, application of some kind of an algorithm, generation of the model, and then deploying that model, or visualizing that model, or performing some kind of an analysis from that model which we have got. Okay, so what data science exactly does is, as I told you, I consider it as a 4-step process: asking the correct questions and analyzing the raw data. So analyzing the raw data means whenever you are doing the data collection, it may not be in a format so that I am going to use it directly. Then I'll model the data using various complex and efficient algorithms. So, and then visualizing the data to get better perspective, and finally understanding the data to make better decisions and finding final results. Now, what is very, very important in this slide is for you to realize that every slide contains this word, right? Data, modeling the data, visualizing the data, and understanding the data to make better decisions and finding final results. So the core or the heart of data science is availability of too much of data. If you have too much of data available with you, then only are your data science algorithms going to give you good results. So that's very, very important for us to understand, right? And how do you discover knowledge through data? If you all would remember, in this particular slide, I told you there is a lot of data, but there is no knowledge that we are discovering through data. So a typical knowledge discovery through data process will comprise of these steps. So you'll have databases which may come from various sources. So you may have multiple data sources. You do a data cleaning and store this clean data into a data warehouse. Then whatever task is given to you, you select the relevant data on the basis of that task and apply it for data mining. I gave it to you. This taking is out. Asking. And then you apply some kind of a data mining algorithm here and evaluate the patterns to gain knowledge. What does this mean? Of course, when I'll demonstrate Weka to you, it will become very clear to you what do I mean by this knowledge. That what am I trying to gain as far as knowledge is concerned in this process, right? And this is a typical view from machine learning and statistics. So if I consider knowledge discovery through data process from a machine learning and statistics viewpoint, what exactly would data preprocessing mean? Data preprocessing would mean integrating the data from multiple sources, normalizing, that is, ensuring that all the attributes fall in a specific value range. So when I'm normalizing, maybe I expect all the data values in a particular column to be between 0 to 1. So I'm going to divide it by the maximum value of this particular column so as to get the value between a range of 0 to 1. Then you come to feature selection. So are all the features which are there available in my data set essential for me? If they are not, I might select certain features and I might delete certain features so as to reduce the dimensions. Why is this dimensionality reduction required? Because the data available to us is huge. As the data available to us is huge, these dimensions need to be reduced. And then you come to data mining. What exactly am I going to do in mining? I am going to discover patterns. I am going to discover associations or correlation between various data points. I might classify this data. I might cluster this data, or I might analyze outliers. What are outliers? Data which is not in conformance with the rest of the data points. So maybe let's say I have got a data set in which all the students have marks above 70%. But there are two students who have got 100% marks. So those two students will be called as outliers. Outliers are the deviations from the regular data points. All right. And these outliers may sometimes be very, very important to us. For example, in an agricultural, let's say in an agricultural setting, if I'm taking some kind of a data from a field, I see that all plant data has got certain parameters, but there are two plants or two fields where the values of the parameter are coming very, very different. So those two fields might be treated as outliers to understand why are the plants only in these two fields dying and not in the other two fields. So that is sometimes outlier analysis may be very, very important. And then post-processing, I may evaluate the pattern, I may select the pattern, I may create some kind of a visualization out of these patterns. So this is a typical view as far as machine learning and statistics is concerned. All right. So these are the various components of data science. You need to know statistics. You need to have domain experts who have the knowledge of what domain are we talking about. The importance of these people is extremely high. Because let's say you ask me to do a project on agriculture. My domain is computers, not agriculture. So I may not be able to differentiate which particular parameter is essential for doing some kind of an analysis and which parameter can I easily skip. So this is very, very important: data engineering, advanced computing, and visualization. And as you can see, data science is an amalgamation of everything, of machine learning, mathematics, statistical research, domain expertise, data processing, and computer science. So you need to have at least in Hindi what we'll call as gyan of all of these domains so as to become a good data scientist. And this is the spectrum of data sciences. You may have reporting, business intelligence, predictive analytics, machine learning, and artificial intelligence, where the complexity of artificial intelligence is the highest and the complexity of reporting is the lowest. So you can actually do reporting using a normal Excel sheet also. Whereas for artificial intelligence, you may require sophisticated tools like Python, R, so on and so forth. All right. So that's how your data science spectrum is. What are the various reporting and business intelligence tools for data science? So you may have Excel, you may have Qlik, Weka I'll be discussing today. You may use Tableau, Google Analytics, Power BI, MicroStrategy, so on and so forth. So what we will be focusing on today is the Weka tool for data science. Let's have a look at Weka. So as you can see, Weka was introduced by, actually it's a data mining tool which was discovered, or which was created by University of Waikato in New Zealand. And Weka is a bird which is very, very popular in New Zealand. That's why they gave it the name of Weka. So Weka refers to this bird which you see on the left hand side, and the tool is called as Weka and developed at the University of Waikato. So I'll give a software overview before we move on to the demo. So I'll be doing demo parallelly so as to make it clear to you. What is Weka? So Weka full form is Waikato Environment for Knowledge Analysis. And it's a collection of the state-of-art machine learning algorithms and data processing tools implemented in Java. And it was released under the GPL, that is Java programming language. And the algorithms can be applied either directly, or the dataset can be called from your own Java code. So it's very, very convenient. If you know programming, you may prefer to use your own Java code. If you don't know programming, very good. It has got something where you can directly apply your data set, and then you can apply all the filters or all the classifiers on your data set to get the output. Okay. So support for the whole process of experimental data mining, preparation of input data, statistical evaluation of learning schemes, visualization of input data, and result of learning. So Weka contains tools for data pre-processing, classification, regression, clustering, association rules, and visualization. And it is also used for a lot of learning resources. So what are its main features? If you look at this tool, it's amazing. It's got 49 data pre-processing tools, 76 classification or regression algorithms built in, 8 clustering algorithms, 15 attribute or subset evaluators plus 10 search algorithms for feature selection, 3 algorithm for finding association rules, and 3 graphical user interfaces. This is what I love about Weka, because Weka has got something for everybody. If you, let's say, if you want to just explore, you can use the explorer. If you want to use the Weka for experimentation, you can use the experimenter interface. And if you want to check the new process models inspired interface, you can use the knowledge flow. I'm going to show you all this. And where to find Weka? The latest version of Weka available is Weka 3.9, and this is the website where if you go, so let me just click. You'll have to tell me whether the website is available, is visible or not. Can you all see the website? Is the website visible? Can anybody of you confirm if the website is visible?
No, ma'am. It's not
Just
visible.
a second. I'll probably have to reshare it. Just a second. Yeah, because that's the problem with, yeah. So this is the Weka website. I'll be sharing the link in the chat. So any one of you who wants to do it along with me can definitely go to this website and download Weka from there. So I've given you the link to Weka. So this is from where you can download Weka, and you can see over here. So download, you just go to download and download Weka. And as you can see now, Weka has been interfaced. So it is widely used, and it has well-known toolboxes to transparent access to toolboxes like scikit-learn, R, deep learning 4J. You can integrate it with any kind of these new age machine learning softwares. Okay, so this is how where you can download Weka from. And of course, there's a manual also available of Weka, which you can read through, and you can get all information about Weka. Okay, so let me just stop this share. This is a slight problem with Zoom, that every time you want to share something new, you have to, yeah. So I'll come back to my slide. Yes. So this is where you find Weka. And as I told you, Weka has got two interfaces. One is the command line interface, another is the GUI. So let me just straight away go to Weka and share it with you. So, and start. Okay. So share screen. 1 minute. I'll just open Weka. Just give me a minute. Yeah. So yes. So if you'll see Weka, what I'll do is Weka has got an explorer, it has got an experimenter, it has got a knowledge flow, it has got a workbench, and it has got a simple command line interface also. So if you are a hardcore programmer, you can straight away write your Java code over here, and it will give you all the functionality. So let me just begin with Explorer. Okay, so yeah, so when I open Weka Explorer, just a second, too many windows got opened. So what I'll be showing you first of all is a very, very simple data set. Now, before we embark on the journey of, so this is how Weka interface looks like. If you can see, it has got 1, 2, 3, 4, and 5 UIs, or 5 different interfaces. You can use it as an explorer, as an experimenter, as a knowledge flow, and as a simple CLI also. So just a second. All right. So how is data stored in Weka? So Weka can take data sets in the form of ARFF. So each entry in a data set is an instance of the Java class. As you all know, basically in Weka, so each entry it will have multiple attributes. So you will have one instance. Let's say this is the data about a plant. I'll write it like that. So let's say it's the data about a flower called as iris. So iris flower has got 4 attributes. One is petal length. Another is petal width. Third is sepal length. And fourth is sepal width. All right. So these are the 4 parameters. So for, let's say this is first iris flower, which I took, the petal length is 20, the petal width is 21, the sepal length is 22, the sepal width is 12. Similarly, for second flower, I will have something, and then I'll have a class. That which class of iris does it belong to? Iris flower has 3 classes: setosa, versicolor, and one third class. So let's say if the petal length is this, if the petal width is this, if the sepal length is this, sepal width is this is iris setosa. So the last column, or the last one, gives me the label or the class to which this particular flower belongs to. So this is how your data sets in Weka are organized. They are organized as instances, and with each instance having a number of attributes. So this is called as an instance, and these are called as attributes. So for instance 1, you have got 4 attributes. For instance 2, you have got 4 attributes, so on and so forth. And attributes may be nominal, numeric, date, or relational. That's the way it is. So what are ARFF files? They are the way data is represented in case of Weka. So each ARFF file, it comprises of a header and it comprises of a data section. So let me just take you to an ARFF file. Okay. Just a second. So this is a small problem which is there in Weka, that in Zoom, that you'll have to every time. Just a second. So I have this, just a second. I will go to my desktop. So if you can see over here, I have got this soyabean.arff file. I'll just open it with a normal notepad. All right. Just look at this ARFF file. What does an ARFF mean? ARFF means attribute relation file format. So in case of Weka, the files are stored in the form of attribute and relation file. The name of the file is soyabean. So it's like an Excel sheet converted into some other format. So the name of this particular file is soyabean, and it has got what all attributes. It has got a date attribute. It has got plant stand, precipitation, temperature, hail, crop histogram, crop history, area damage, severity. So basically this is trying to tell you, the data set is trying to tell you, if you read here, it's a corresponding test database, and this database will tell you whether a given soyabean plant has got some kind of a disease or not.
Ma'am, your
Yes,
notepad
sir?
file is not visible to viewers.
This ARFF file is not visible, sir?
Yes, ma'am.
1 minute. I'll just share it again. Yeah, is it visible now?
No, ma'am. Now visible.
Now visible. Okay.
Okay.
So you have to see that this ARFF file comprises of attributes and relationships. So now every ARFF file will first have some kind of a node, then it will give you a title. It'll tell you what are the sources of the file, who are the people who have used this data set for their research. That means I have data about 683 soyabean plants. And each soyabean plant, I am taking 35 attributes for each soyabean plant, right? And there are total 19 classes. Now, how do I read this particular information? Means I have checked, or I have collected the data for 683 soyabean plants, out of which each plant has got 35 attributes, and there are 19 types of diseases that the plants can have. So the name of the disease is diporthe, stem canker, charcoal rot, or herbicide injury, so on and so forth. So now let's have a look at the data. As I told you, the data actually starts from here. So this is all given as what can be the, so the data starts from here. At the rate tells you what is the name of this particular data set. So the name of data set is soyabean. And then it has got these 34 attributes, which I told you. You can see these are the attributes. So what am I checking about the plant? I'm checking out its standing, what was the precipitation, what was the temperature, what is the plant growth, how are the leaves, so on and so forth. And this is what I define, how many columns does this data set have. And now finally I have the data. So look at the first data instance. It's the month of October, normal, GT normal. So for each plant, I have collected data corresponding to these attributes, which has been mentioned here, all these 35 attributes. So what does that mean? I have got 683 plants data, each plant having 38 attributes. Now you can see some question marks here. These question marks mean I do not have data for these particular values. So now let me import this data set into Weka. Once you've understood this data here, what I'll do is I'll just import this data set in Weka. So in Weka, how do I import this data set? I'll have to again new share this one. Yeah. Okay. So I hope you all are able to see this new share. The Weka interface, are you able to see?
Yes, ma'am.
So just see now, we are going to now see how the data will be treated, or how I will be able to classify data using this particular data set. So I'll open file. All the data by default, which is pertaining to Weka, will be stored in your C drive, program files, you go to Weka. In Weka, there will be a folder called as data. So in data, I have this data set called as soyabean.arff stored. Okay. Soyabean.arff. But before I start with soyabean.arff, I'm going to start with this iris data set. Now you understand how the data set works. So I'm going to use this iris data set. Iris is a flower. Again, the data set will be in the same manner as I told you. So I have got just petal length, petal width, and I have got class. So there are 3 classes of flowers which can be there. An iris flower can be of the setosa class, it can be of versicolor class, or it can be of virginica class. I can also have over here, let's say, visualize. Yeah. So I can also have over here edit, and I can see the data set here. All right, this is ARFF viewer. So I can view the data set here. Now you can see I have got data set, and for each data set, I have got petal length, petal width, and class. Okay, so each data, depending on what is its petal length and petal width, it is given a class. That's what the data set is right now. But you can see, let's say all the data is available. There is no missing data as far as our data set is concerned. So what we are first of all going to do is we are going to apply a filter over here. Okay, so in Weka, I have got a lot of filters which can be used for cleaning or for cluttering data. So what I'll do is, first of all, is I'll use unsupervised attribute. And see, what I'll do is I'll use an attribute called as replace with missing values. So what I'm doing is, in the data set, I'm putting some values as missing values. Let's apply this. First of all, just see the data set. The data set looks like this. Okay, no missing value. Now what am I going to do? I have chosen a filter replace with missing values. So I'm going to remove or erase some values, and I'll say apply. Now you can see I'll go back to the data set, edit, and you can see now over here some values are missing. Is it visible to all? This value is missing. Then over here, this value is missing. This value is missing, which was not missing earlier. So I applied a filter where I made some values miss. Now, if these values have gone missing, is there a way for me to fill up missing values? Of course, I can fill up missing values by doing replace missing values. So these are the filters which I can do, and I'll say apply. And when I say apply, when I edit, you can see the values which were missing have been replaced by some value. What is this sum value? This sum value is the mean of all the values in this particular column. So in this particular column, it took the value, all the values, and calculated its mean and replaced all the missing values with that mean. That's how it automatically does it. Or what we can also do is, we can also, I'll undo this, and we can also use a filter called as replace missing values with user constant. So you can tell with what value. So you double click over here, it will give you the filter properties. So which attribute first and last? What is the missing value replacement? You say replace all values with 1.5 and replace all values with 1.5. And when I say okay, now when I edit it, you will see all the missing, sorry, I have to apply. So apply. And now when I edit, you'll see all the values which had gone missing, those have been replaced with 1.5. So this is the way you clean your data. The first step of pre-processing, as I told you, in data science, you first of all need to see what kind of data do you have. And then you need to pre-process it in case there are some missing values, in case you need data cleaning. So there are a lot of filters available here as far as your data pre-processing is concerned. Okay, so what I can do is I can convert a data from numeric to nominal. Means this data is, it has got, you can see over here, the type of this data is numeric. I want this data to be converted into nominal data. What is nominal? Nominal is something which has got name. So I can simply say numeric to nominal, and which one? I just want the first attribute to be converted to numeric to nominal. Okay. And apply. So now you can see, instead of numeric data, now I have got nominal data, right? So we can undo also what we have done. We will undo everything and come back to our original this thing. Okay. So this is how you first of all apply the filters. So I'll repeat. We open a file. I'll open the file now, soyabean.arff, for each one of you, because soyabean.arff has a lot of missing values. Now let us try and see. So let us try and read each attribute. So what does it tell me? Date. Date is a nominal type attribute. Why? Because date has got values April, May, June, July, August, September, October. What is this? That means out of the 600 data points which I have, 26 data points belong to April. Out of the 600 data points that I have, and there are 7 distinct values. Why are there 7 distinct values? Because I have collected the data from April to October only. That's why there are 7 distinct values, right? And what is the weight? So you can see over here. Now, before I come, what is the aim of this data set? The aim of this data set is that if I give you all these parameters, you have to tell me, does this particular plant have a disease or not? So now you can see out of all the data that I have, there are 20 plants which suffer from diport stem canker. There are 20 plants which suffer from charcoal rot. And you can see there are 92 plants which suffer from brown spot. So I can use this data to understand what kind of a disease is most common. So you can see this data, which is at number 4, that is Phytophthora rot. 88 plants are suffering from that disease, so on and so forth. So this is how we are going to visualize or see our data, right? And now let us look at this particular column again. There are no missing values. There's just one missing value. That's fine. Let us come to plant stand. There are 36 missing values. So should we do something about it? Yes, we should do something about it. We should say replace missing values, and I should take this and replace missing values more. Okay. So if I use this, then it will replace missing values everywhere. Okay. However, if I select this one and say replace missing values with user constant, or replace missing values, so I can choose the values with which I want to replace it. Or if I don't want to choose a value on my own, I can just cancel this and just say replace missing values. So both the options are available with me, whether I want to replace the missing values or I want the system to do on its own. So I'll say apply. Now you can see over here, there are no missing values. So all the missing values have been dealt with or have been taken care of by the filter. Okay, so over here also now you will see, I'll undo once, I'll show you each one of. So over here there was one missing value. Over here there were 36 missing values. Over here there were 16 missing values. Area damaged, 1 missing value. Severity, 121 missing values. So when I said replace missing values and I applied the filter, immediately you will see severity, there is no missing value now. So all the missing values have been replaced by some value which is either a mean, median, or some kind of an mathematics it applies behind, and then it fills up those values with that missing values. Okay, so there is a lot of filters which you can try over here, and you can try it with your data set, and you can do a lot of you may swap values, you may sort labels, you may standardize, you may normalize, you may convert data from ordinal to nominal, from nominal to numeric, depending on from numeric to binary. Let's see, when do we convert numeric to binary? Let's say stem has got only 2 values. It has got norm and abnorm. So that means it's a binary value. Either it will be normal or abnormal. So what I can do is I can choose a filter called as binarize. So this is nominal to binary, nominal to binary. Okay. And when I apply this filter, just look at what happens to stem. So let us come back to stem. Stem. Yeah. So it has binarized, and now you can no longer see stem as a single this thing. Now you see stem abnorm. So this is how it has converted this data into numeric data now, which was earlier a nominal data, right? So this is how your pre-pari was. So this is the first step that I made. So this is what we just now did. I showed you what ARFF file format is. So the file format comprised of attributes, relations, and then it comprises of the entire data. So you have a header which describes the attribute types, and then you have a data section which comprises of the comma separated list of data. And then I showed you how an ARFF file looks like. So this is the data set name always you will have @relation, which is the data set name, and then you will have multiple second array, and then you have the data. So for instance, when I saw weather on the first day, the outlook was sunny, the temperature was 85, the humidity was 85, windy was false, and the person did not play. So this last column is the class variable, which tells us what class does it belong to. Now, on the second day, when I took the temperature, it was sunny, the temperature was 80, humidity was 90, windy was true, the person did not play, so on and so forth. So this is how an ARFF file looks like. So an ARFF file basically comprises of two parts, sorry. This part is called as the header, which tells you what all attributes are there. And then you have the data, which is in the form of comma 7. So if I had one and so forth. Okay, this is how your ARFF file. And as I told you, what are the functionalities which are available in Explorer? You can pre-process, you can classify, you can cluster, you can associate, you can select attributes, and you can visualize the data. I already familiarized you with this GUI interface. So you already saw how to open a file, how to apply some kind of a pre-processing technique on it. And data can be imported from a file in various formats. You can import in ARFF, you can import CSV, but generally you use ARFF file format as far as Weka is concerned. And pre-processing tools in Weka are called filters. I have just now showed you some filters. Weka contains filters for discretization, normalization, resampling, attribute selection, attribute combination, and so on and so forth. So the first part of the entire demonstration I've shown you how to pre-process the data. So you just need to load this ARFF file into Weka, and then you can apply multiple filters on this ARFF file. Now, once you have, what does pre-processing actually comprise of? Loading the data, pre-processing the data, and analyzing the attributes. So we have done all three of these processes just now. Now, what we are going to do is we are going to see, or over here, if you see, the way I opened a data set, similarly another data set called as weather has been opened here. And you can see these are the three. Download Weka manual. You can go to page 15 and 16. It'll tell you what all filters are available. 26 filters are available. So impossible for me in a 1 hour session to familiarize you with all those 76 filters. But filling in the missing values is most common filter which is used as far as Weka pre-processing is concerned. Now, after we have done the pre-processing, what is to be done? Now, the second step is that we will try to build classification models. What do you mean by classification models? Classification model means right now I have a data set in which I know that if these are the parameters, what is the disease? So a classification model, what it will do, if I just give you these parameters, it should tell me what is the disease. Please understand. I train the model with this data, which tells me that if these are the parameters, what can be the disease. Then I test the model by giving it only parameters and letting it predict the disease. And then I compare this predicted disease with the actual disease. If this is same, I say my classifier is 100% accurate. If this is not same, then I say my classifier is 0% accurate. Okay, similarly, if I give it 10 data sets like this and ask it predict the data for each of the plant attributes. If out of 10, it classifies 8 as correct diseases and 2 as incorrect diseases. So what is my accuracy, classifier accuracy? It's 80%, so on and so forth. So let us see how classification models are built as far as Weka is concerned. Okay, so we'll go back to the Explorer, share. Okay, so till here, is it clear? How do we load data? So now let me come to the next tab, which is the classifying. Now over here, what we have done now is understand we have loaded the data, we have pre-processed it, we have transformed it, we have analyzed all the attributes that we had to. What I'm going to do is I'm going to undo and get the data back into the original. Oh, my mistake. Open file. Or what we'll do is we'll just take a smaller data set for you all to be easily able to visualize, and then we'll probably come on. So this is another data set. Open file. Just give me 1 minute. Yeah. So this is the iris data set in which now you can see there are 4 attributes: sepal length, sepal width, petal length, petal width, and class. Let me just understand this data. What does this mean? The first blue color is iris setosa. The red color is iris versicolor and the blue color is iris virginia. I have in the entire data set, I have got 150 instances. Okay, that means 150 data points. Out of those 150 flower samples which I have taken, for which I have the sepal length, sepal width, petal length, and petal width, 50 of them belong to Setosa class, 50 of them belong to versicolor class, and 50 of them belong to virginica class. Now let me come here. What does this mean? This means if the sepal length is 4.3 to around 5, the chances of the leaf being iris, what is blue color? Iris setosa, are more. I'll repeat. See here at the bottom, I say if the leaf, if the sepal length is between 4.3 to 5, the plants are all iris setosa. However, when the petal length becomes 5.843 to let's say around 6.875, it becomes iris versicolor, and rest all its iris virginica. So this shows what will be the value of the sepal length, and accordingly what class can the flower be. Similar for the sepal width, now you can see, and petal width and petal length. So this is the data set that we are currently looking at. Now I'll open this classifier. So there are no missing values, you can see. I don't need to do any pre-processing because there's no missing value here, no missing value here, no missing value here, no missing value here, and no missing value here. So I go to classifier and choose a classifier here. As I told you, Weka has around 39 classifiers. So let me first of all apply something called as a naive-based classifier. I'm sure all of you must be aware of this. And there's something called as a cross-fold validation. Now, what does the cross-fold validation mean? I have got a data set of 150. So what I'm going to do is, if I say 10-fold validation, I'm going to divide this data into 10 folds, with each fold having 15 entries. At a given point in time, I'm going to use 9 folds for training and 1 fold for testing. I'll repeat. Let's say I have got a data set in which, in fact, I have a data set called iris in which I have got 150 instances. When I say 10-fold cross-validation, what does that mean? That means something like this. Just give me a minute. I'll share my Microsoft whiteboard with you. So it means something like this. Yeah. So it means something like this. Let's say I have got a data set with 10 data points. All right, I have got a data set with 10 data points. And I'm using a 10-fold cross-validation. All right, treat this as 10 data points. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. When I say 10-fold cross-validation, what does that mean? That means I'm going to divide this entire data into 10 parts. In the first go, I'll use these 9 values for training and this one value for testing. In the next round, I might use these 9 for training and this one for testing. In the next one, I might use 1, 2, 3, 4, 5, 6, 7, 8, 9 for training, and I might use this for testing. That's called as 10-fold. If I do 3-fold validation, what does that mean? That means I'll divide this entire data set into 3 folds, into 3 parts, 1, 2, and 3 parts. In the first part, I will use these 2 for training and this one for testing. In the next one, I'll use these 2 for training and this part for testing. And in the third one, I'll use these 2 for training and this one for testing, so on and so forth. So that's how it is going to work. And let me come back to my Weka. Yeah. Yes. So I will choose naive-based classifier over here. I have used a 10-fold cross-validation and I'm going to predict the class label. So let me start. Once I start, please look at this carefully. It took a fraction of a second. Correctly classified instances are 144 and the classifier accuracy is 96%. All right. And the incorrectly classified instances are only 6. So out of the data set of 150 that I had, when I applied a naive-based classifier, I got a classifier accuracy of 96%. You all would be familiar with this, called as confusion matrix, which tells you how many true positive, true negative, false positive, and false negative are there. So if we just look at this particular matrix, now what does it tell me over here? It tells me that 50 instances which were A have been classified as A. There is 0 instance which was A which has been classified as B. There is 0 instance which was A but has been classified as C. Similarly, 0 instance which was B which has been classified as A. 48 instances which were B are B, and 2 instances which were B are actually classified as C. So you can see this if you will see this total 2 plus 4, that is 6. These are the 6 miscorrectly classified instances. You can see it over here. This is 2. This has been misclassified, and this 4 has been misclassified. So total misclassified instances are 6. So if you are trying to do some kind of a research with an agricultural data, you just need to do this, pick up these parameters, and you can present them as your results. That this is my true positive rate, false positive rate, precision, recall, F measure, ROC, PRC. So this will completely give you the result. Let me apply another algorithm and see what happens. I'll apply a tree algorithm. Let me use J48 tree. See, I'm not changing anything. I'm just applying the tree algorithm. And now you can see again the accuracy is 96%. Let me try and visualize this tree. So I have visualized this tree. So this tree gives me an output like this. It says if petal width is less than or equal to 0.6, the flower is always Iris setosa. I don't need to bother about other parameters. If petal width is greater than 0.6 and petal width is less than or equal to 1.7, petal length is less than or equal to 4.9, then it is versicolor. So like this, the tree, now if I ask you, okay, I have a flower in which the petal width is 1.7 and the petal length is 4.8, what is its class? So you can easily come from here till here and tell me that it belongs to the class Iris versicolor. It's beautifully visualized also over here. As you can see that the visualization of trees and everything is very, very beautiful here. And what I can also do is, I can also see over here now, you can see now it is misclassifying 1A as B, 3 Bs as C, and 2 Cs as B. But overall, incorrectly classified instances are 6. Now let us see what will happen if I change the cross-fold validation. If I change it to 3 and I start. Now you can see over here, the classification accuracy decreased because I am giving lesser training to the data. I am training it only 3 times. First time with 2 partitions and testing with 1 partition. Second time with 2 partitions and testing with 3rd partition. And third time with 2 partitions and testing with 3rd partition. Similarly, over here, the number of misclassified instances have increased from 6 to 10. All right. So there are so many classifiers over here which you can try. So there is a function of meta classifiers. They are also called as classifiers of classifiers, where they are a combination of multiple. So if I do this multi-class classifier, and I'll use the cross-fold validation of 10 only, I'll start. And now you can see because the data set is very small, there is not significant difference. So what I'll do is I'll open a file quickly called as soyabean. Open. Okay, I'm not going to do anything as of now. There are a lot of missing values, so I am not doing anything. What I'm going is I'm going directly classify, and I am using a tree classifier. Okay, a J48 classifier to classify this stuff. So you can see now the confusion matrix is huge. Why? Because the number of classes are 19. In this case, the confusion matrix was small because the number of classes in the data were only 3. Iris setosa, Iris versicolor, and Iris virginia. Here, the number of classes or the number of diseases that a plant can have are 19, 1 out of the 19. And you can see now the confusion matrix is huge. And also you can see out of all the entries that we have, how many attributes do we have? How many instances do we have? We have 683 instances. Out of them, 625 got correctly classified and 58 got incorrectly classified. Let us try and pre-process a bit and fill in the missing values. That's what I'm going to do. Okay, before I do this, let me just come to the data set. You can see this data set, just watch it clearly. There are going to be a lot of missing values in this. Can you see? There are a lot of missing values in this data. So what I will do is when there are missing values in the data, the accuracy that I have got is 91%. Let us try and fill in the missing values. So I'll come over here and say replace missing values and apply. All right. So it replaced the missing values. Now let us look at the data. When I look at the data now, Now there are no missing values. All values have been filled up by something or the other. So now let me apply the, just a second. Yeah. So, okay. What I'll do is I'll apply the same classifier. I'm not going to change anything. I'll apply the same classifier again. And now you can see the accuracy increased from 91 to 92% by handling missing values. So 1% accuracy improvement I have seen when I fill up these missing values. Also, I can apply other classifier algorithms also to see how good this particular algorithm works. Okay. Similarly, this is classify. When do you classify a data? When your data is labeled. That means in my data set, I already knew what are the labels of my data. All right. When will you use clustering? You'll use clustering when you do not know the last label. Okay, so over here you'll see in classify, it tells me on the basis of what attribute are you trying to classify. However, in case of clustering, I'll have nothing like that. So let us use a clustering algorithm. I'm sure you all would be knowing simple k-means clustering algorithm. When I start and use k-means clustering algorithm, you can see how many clusters are formed. It has formed only number of iterations 10 within cluster sum squared. So how many it has formed clusters. Okay. So over here, these many clusters have got formed. Cluster number 0 and cluster number 1. So all the data, all the trees which are there have been clustered into 2 clusters, depending on their similarity. Now you'll see over here, it's a different technique altogether. Here you are not saying what is the disease. Here you are grouping together all the plants which have got similar kind of attributes. Right. So that's it from my side. Actually, this topic is unending. So what I'll do is I'll just go back to my slide. Give me a minute, please. Yeah. And yes. So as I told you, in classification, you use the training set, you perform the percentage split, or you use cross validation. Percentage split is, I may say 66% split. Means I'll use 66% of the data for training and the rest 33%, 34% of the data for testing. Or I may use a cross validation, or I may use a separate training set. So all the three things are same. We run the classifiers and then we view the results. So I'll quickly come over here. As you can see, one classifier I have run, so I can visualize the tree as I showed you. This way the tree had come for us also. We saw that tree as well. And I can also visualize the what is the way different attributes are behaving, or what are their generic values, or how are the what is the distribution of classes, so on and so forth. Okay, so this we have already seen, right? I can also apply neural networks, and I can visualize neural networks as well, right? There are a lot of classifiers available. So this is how you're going to visualize a neural network, right? And this is how your results are going to look like. I just now showed you. So depending on what kind of a classifier have you used, accordingly your results are going to look a bit different. If you have used a tree, you are going to get the tree as a visualized result. If you are using a naive-based classifier, you are going to get what is the result that you are going to use is the confusion matrix, so on and so forth. So this is for another example, and this is for the soybean.arff dataset, which we just now saw. So this is the way our accuracy came, but you can see over here, the accuracy that has been obtained is only 88%. Whereas when we run the algorithm gave us an accuracy of 91%, right? Because here here I had used a different classifier as compared to the one which I have shown you. And this is the precision and recall measures which are used for calculating the efficiency of a given classifier. Okay, so this is how your confusion matrix of the soybean results look like, right? So as I told you, there are more number of classifiers. I have discussed some of them with you. Please experiment it on your own. This is all about experimenter. So I'll stop sharing. Yes, I'll come back to the meeting. So that's it from my side. In case you have any query, I'll be more than happy to answer that.
Can you see? Yes, I use it.
Yes. Thank you so much, ma'am, for this wonderful hands-on session. Ma'am, we have one question
Yes.
that how we can create ARFF file?
I was expecting this question. Very, very easy and simple question. So see, let's say you have an Excel file. Now, what does Excel file comprise of? It comprises of attributes on the top, and then you have the data. So how do you create an ARFF file? You simply open a notepad, give it the name @relation, let's say XYZ, whatever you want to name your data set, and all the column names, you put them as attributes. And then the rest of the data which is there, copy it, paste it, and put commas in between that, and save it as a .arff file. That's how you create ARFF files. Otherwise, there are tools available online also where you can give an input as a Excel file or as a CSV file, and it'll convert that into ARFF, and vice versa also.
Thank you so much, ma'am. One another question, that can we select average value?
Yes, you can. I had told you that there is a way that you can replace the value with user defined value. So if you want to use average value, or you even have a provision on top of the attribute to check what is the average, what is the mean, what is the standard deviation. So you can use any one of those values to replace the missing value. That is your choice, how you want to replace the missing value.
Okay, ma'am. Once again, thank you so much for this wonderful session. Now, moving further towards our third technical session, which is delivered by Dr. Rajni Mohna. Just wait a second. Uh, Dr. Rajni, ma'am, are you there? Okay.
Ayushri, with your permission, can I just take 1 minute?
Yeah, sure, ma'am, sure.
Yeah, I would like to thank Dr. Chetan, though 1 hour is a very small time for me to cover such a vast tool called Weka. But as I have given you the link also for Weka and the manual also for the same, I'll recommend you all kindly go through it. And in case of any query or any help that you require, I'm just typing my email ID on the chat. You can please get back to me. It'll be my pleasure to be of any help to all of you. And I would like to once again thank Dr. Chetan for this opportunity. It was wonderful, though, as I told you, 1 hour is very small time for covering a tool in entirety, but I tried my level best to at least give you the supervised learning concepts of it completely. Thank you so much.
Yes. Thank you, Dr. Meenakshi. For in short period of time, you explain very well by using the examples in Weka. Thank you.
Thank you so much. Thank you. May I leave the meeting, sir?
Yes, ma'am. No problem.
Thank you so much. Thank you.
Thank you. Now, let me first introduce our third guest speaker, Dr. Rajni Mohna. She is currently working as Associate Professor in the Department of CSE at Jaipur University of Information and Technology, Himachal Pradesh. She has over 17 years of experience in academia. She has completed her PhD degree in Computer Science and Engineering from Jaipur University of Information Technology, Solan, Himachal Pradesh in 2013. Dr. Rajni has published around 20 papers in various well-known and Scopus journals. She has guided 2 PhD students and is currently guiding 3 more students. She has guided 4 postgraduate students also. She is also a reviewer for various renowned international journals and international conference. She was TPC chair and TPC co-chair in 2015 and 2017 respectively in an international conference on image information processing at JP University of Information Technology, Solan. So with this, I would like to request Dr. Rajni ma'am for start the session. Please, ma'am.
Yeah, good afternoon, everyone. Am I audible?
Yes, ma'am, you are audible.
Okay. First of all, I would like to thank Dr. Vyas, VC sir of your university, and Dr. Chetan and his team for a wonderful uh, the workshop, wonderful workshop. And though, as Dr. Meenakshi also said, that it's very difficult to cover everything in 1 hour, but I'll try to, cover things so that it gives you a motivation to work on R. So my work would be, or my session would be based on R only, and I will be covering the concepts, basic concepts of R. So let me start my presentation. Let me share my screen. Is Is my screen visible?
Yes, yes, ma'am.
Okay, as I said that today's workshop is on data science tools, so I'll be focusing on R only. And as we know from since morning, you must be knowing that why data science is important, and in today's world, why data analytics is important and all those things. So I'll not be covering that. I'll just jump into R so that you within short span of time you get maximum out of it, right? So there are, we all of you know that there are various tools in it, like data science tool. We have MATLAB, we have Stata, we have SAS, we have SPSS, Tableau, then R, etc. Right now, let's focus on what is R. R is an open source programming language available on every major platform. Open source in the sense that anybody can code it. Like suppose if I don't like something or I want to do some features on it, then I can write my own function and upload my function, and anybody can use that particular function. It was developed initially by these two authors, Ross Ehalka and Robert Gentleman, and as both names, the coder's name started from R, so hence the name R came into picture. It is dynamically typed interpreted language. I'll explain about it more in when I'll start with the R hands on. And it is a very popular field for statistic, machine learning, visualization, and data manipulation. So I'll be covering today. I'll not be covering about machine learning and statistics because it will be too much. I'll be working on visualization and data interpretation. So it is supported by the package system called CRAN, where you can find packages related to the wide range of fields. So as I said that it's an open source, so you can create your own free, functions, and then create a package and upload that particular package, and anybody can use that package. So that is why it is called as a community based project. Community based project means people, there's not, it's not, all are the partners, right? Suppose if I want to make a name of myself in R, so what I'll be doing is I'll make my own package and I'll upload it so anybody can use it. So with this, obviously the disadvantage is a lot of redundancies also there, like the same work, same function, but I want to do it in a little different way, so I'll create my own package. So that has come to an add-on package of nearing 8,000. So we have in our, currently we are having more or less 8,000 packages, right? So here even a lot of exercise data sets are also available, like MT-car, iris, diamonds, etc. These are the sample data sets available with the within R, and you can just practice your functions and everything on that. The first stable version of R came in the year 2000, and till now it is updating and upgrading. So what does R can do for you? So anything which you want for data analytics, everything R can do it. So R can go for data entry, data pre-processing like cleaning, changing, deleting, and filtering of data, statistical analysis like machine learning and prediction, which Dr. Meenakshi has also a little bit specified about machine learning techniques and all, data simulation to various degrees, visualization up to complex graphs. And nowadays R is also working or also having web scraping functionalities, which is meant for the Twitter analytics. Like suppose if I want to work on the live feeds of Twitter, and I want to find out what is the opinion of the farm bills of the people, right? So how do I work on it? I can use this framework called as R Shiny, and with which I can integrate my website and I can visualize my data. Now, what are the alternatives of R? As in my first slide, I've talked about that we have MATLAB, Minitab, SAS, and SPS. So depending upon the audience, this is picked, right? So MATLAB is generally meant for engineers. Minitab is meant for quality control and Six Sigma. SAS is meant for clinical research and track development in pharmaceutical companies. right? SPS is used for academia, but nowadays R is also gaining popularity in SPS, gaining popularity over SPSs. Now, if you're looking for a career in academia, then you should transfer from SPSS to R. Maybe many people would be offended, but yes, because you can, implement machine learning, and you can do a lot of things, and you can, code things on your own. So, and it is again a freeware and open source. So that is the advantage of R. So Excel has some overlap with the data entry. And a lot of visualization things you can do in the Excel. So still I would prefer that R is also gaining the terrain, and people are switching to R. Now, how to install R? That's the first step you need to do when you work on R. This is the link which I have given. I'll share my PPT also. So from the this particular R Studio website, or from the CRAN website, as I said that CRAN supports this, you can install R. So first thing is you need to install R, and then R is a command prompt based. So the coding becomes little difficult over there. You need to write the command on the console. So that becomes a little difficult. So if you are a beginner and you want to work on it, then R Studio you have to install over on the top of R. And it is a GUI which is to be installed on the top of the R. So when it is very easy, you need to just download it according to your specification. If you're having according to your operating system, you need to download the exe file, and as the system prompts, you need to just click on that and go for the default you know default packages or something, and then it will automatically get installed in your system. So once it gets installed, this kind of screen you'll be getting. There are 4 panels in this, right? What are the 4 panels here? The source is there, the code, right? I'll be showing it when I open my R Studio, but this is the 4 panel, right? Here is the source, here's the console, here the file, plot, packages, and help. These are the 4 things which are available over here, and the environment and history. So this is how the R Studio looks like. So let me start my R so that we can work. And yes, before starting with the R, one thing which I wanted to mention was that the data set which I've used is from this website. It's a crop production web CSV file, input file. So what we did is that what this file includes is state wise, district wise, what is the crop production, what is the area of that particular crop production, and what is the season, whether it is kharif, rabi, or throughout the season the crop grows. So all those details are there in this, and I thought that this would be the best a good data set to visualize or things. So I picked up this data set. So let's move to my R Studio. This is how the R Studio looks like. So initially it's a clean slate. I have actually just to save time, I've made the scripts. I'll be running these scripts one by one. I'll be running the commands to show you how the things works. But initially it's a blank screen. Is my R Studio visible?
No, no, ma'am. Please share again.
But
Please stop sharing your PPT and
okay.
share again.
Okay. Share screen, and yeah, I need to do this. Is this visible, sir?
Yes.
Okay.
Yes, yes, ma'am.
Okay. So, so as I talked about that, these are the 4 windows which opens. Here is the console, here is the script where you write, and here is the global environment, and here's file, plot, packages, help, etc. is there, right? So first of all, what we'll do is initially it's a blank, like I'll show you this. Initially it's like this, the blank screen. Then whatever you write on it, you can just save it in the form of a script, which I have done it, right? So that you can execute it later on, or you can transport it from one machine to another, right? So second thing is console. Whatever command you write, when you say run, you press run, that comes over here in the console. and then it gets executed. So if you have created a variable, those variable listing comes over here, or any data set if you have created, that list comes over here. So this global environment is talking about that, right? And coming to this place, so this gives you the details of packages which you have in your system. Many are, user defined, and few packages which I have, created. I'll tell you how to, download the packages. So anyways, the list of the packages which you have, added comes here. The plots, if whatever plotting, graphs I will be plotting, that will be shown up here, right? And any help, if I want, suppose if I want a help in on any topic, that I can write over here. So these are the things which is there initially. So first of all, if you want to, change the look and the feel, because the fonts are very small, so what I'll do is I'll try to just a second. I'll try to change the appearance of it so that it's little more attractive. Let's see whether this looks fine, and then I can increase my font also. So this way I can increase my font, and I can just say apply. Yes. So this gets applied over here. Now let's start with the R. So just a second, it's my mistake. Is my screen visible?
Still not, ma'am.
I don't know where the mistake has done. Share.
Yes, ma'am, your presentation is visible.
I am actually, I don't know where it went wrong, but I am trying to share again. Our studio got closed. Just a minute. This is what happens when you are in a hurry. Anyways. Okay, I hope it's clear.
Yes, now visible.
Yeah, okay. Thank you, sir. So let's see how the variables are created in R, right? So first of all of you know the data types can be character, numeric, Boolean, right? Complex. So these are the factors, list, vectors. So these are the data types which are available in your R. We are going to see that, right? So first thing is, suppose if I run this, so either I can just write down A is equal to like, suppose if I write it here also, I can, if I write, then also a variable is created, and its value is given on the global environment. In this box you will get whatever variables you have created, right? Or what you can do is, like, suppose if I want to find out what is a class or a type of this variable A, so the function is class A. What I need to do is, I can do this way also, run, so that a command comes over to the console automatically. Class A is executed, and you get the answer that it is a character type, right? Similarly, if you want to assign numeric value, so how do you do it? You just write b is equal to 4, run it, and another variable b with its value is stored or it's shown in the global environment. Now, if you remember in the slide, what did I say? It's a dynamic typed language. What does that mean? That means you don't need to, like in, if you have worked in C, C++, so you need to declare the variable initially, right? So you have to write down int b, then only you can, assign integer value to the particular variable. Here, dynamically, it sees that what is the input, and depending on that, it will assign the type to that particular variable. So here, if I write down class b, then its type would be numeric. Similarly, if I want to create a Boolean variable, then in that case, c is equal to true or c is equal to false, because Boolean has two types of values. Either it will be true or either it will be false. So you need to just write down c is equal to true, and then a variable called as c and its value is created. So this is how it works. Suppose if I see its class, let's see what is the class. It is logical or Boolean, right? Similarly, if I create this is just, I didn't want to type it because it will take time. So what I did is I created a script for you. So d is equal to 7 plus 3i. So all of you know this is a complex number. So let's see when it runs. So the variable is created, and if I see its class of D. So class function is to tell you, or it returns that what is the type of that particular variable. So R supports what? Dynamic declaration. Another feature of R is it is case sensitive. So if it is small d, capital D will not be recognized. Let's see this capital D if it works. So it says that this is not available. So it has generated an error. Similarly, if you want to assign a particular value to a variable, then in that case, these are the three operators which you can assign. T is equal to A, that means whatever is assigned to A, what is there in the A? It's a character, right? So that will be assigned to a new variable, that is T. Naturally, its type will also be character. So if I, this way also I can, execute it. So T is created and it is of type, and the value is just copied. The other way of doing it is with this arrow, right? So arrow can be in both the direction, anything, but it should be from the source to the destination. The source is 2 and T is my destination, right? So if I execute it, now the T's value gets changed and now T is a numeric type. Similarly, if I execute this, then the value of b was 4, so that gets copied to t. So anyways, in any three ways, these are the three assignment operators which you can use. Now, what are the various arithmetic operations which are allowed? We all know that arithmetic operations are plus, minus, subtraction, multiplication, and division. Now suppose a variable is there, num is equal to r plus c. R is 10 and C is 12. Okay. So when we add it, so first we had need to execute. So if you want to execute multiple instructions together, then you have to select that all the three instructions together and execute it. So num is created, num is created and you get the value. Similarly, R and T is also created because we have executed these two lines. I use two different assignment operators over here to show. Then R and T, and then num is created. Sorry, R and C, I'm sorry. R and C. So num is created and the value of num is there. So if you print num, either you can write down print num or you can just write down num. So if I just write down num, it will give me the value of the variable, which is 22 in this case. Similarly, if I want to do a subtraction operation, just I have to use the subtraction operation, R minus C, and execute it. I'll execute. So minus 2 is the value and that gets stored. So num gets overwritten here, minus 2. Similarly, if you want to do a multiplication, num is equal to R into C. So hence, you don't need to write or follow a syntax the way in arithmetic, addition, subtraction, you write down. So that is why it is very simple to code. Even if you are not a good if you're not a coder, then also you can work on R. So it is that that pretty easy, right? So R into C, you have to just write down, and just if you write down num, it gets printed. Similarly, if you division operator, if you run it, so you get a division value divided by, the R is divided by C, and the num gives you the value of R by C. The next type of operator is relational operators. Relational operators are greater than, that means the output of it would be 0 or 1, whether R is greater than C, or R is less than C, R is equal to C, or R is not equal to C. So these are the various relational operators which are there in R, right? So let's see, R is greater than C. If you run it, so it's false, because R's value is 10 and C's value is 12. So this is not true. Now, so as I said, that output of it would be a Boolean value or a logical value, right? True or false. So R is less than C, it's true. R is equal to C, naturally it is false. So you can just write down. So this is the comparison operator also, right? So you're comparing two variables, and whether R is not equal to C, that's true. So hence you get a true value. Right now we are not saving this value in a variable, so that is why it's not stored in the global environment. It's just the temporary variable, and which is shown on the screen. Now, next type of operators which are there in R is logical operators. Logical operators are true and sorry, and or. All of you know, we have. I assume that all of you know that what does and do. So true and true is true. True and false is false. True and false and true is false, and false is false, right? So this so this is how it works. So y is equal to true, I had created a logical operator. Z is equal to true, another logical operator, and then y and z. So we are saying y and z, that means true and true, so output should be true. So the output here is true. Similarly, or, for or we have true and true or true is true, true or false is false. So let's say, let me change this, because yeah, it's case sensitive, so you have to be careful with that. So again, if I have to run, because I've changed the value, so now y is equal to true and z is equal to false. And if I execute y or z, so let's see what the answer is. So true or false, it's true. The output is true. So these are the logical operators which are allowed and or on the in the R, right? So what are the various data structures in R? So suppose if you want to create arrays, vectors, etc. So then let's see that how we can create it. So various data structures which are supported by R is vectors, list, matrices, array, factors, and data frames. So these are the 6 data structures which are supported by R, right? So inbuilt data structures which are supported by R. Now what is R? Vector? Vector is list of homogeneous data. Homogeneous matlab what all members are there, or what all members are there, they are of same type. That means it's a vector of what we say numeric values, or it is a vector of character values, or it is a vector of logical values, right? So this is an example of it. How to write it? Vec 1, this is a variable which I have created. This is an assignment operator. And what is C? C is a combine function, so it is combining. Okay, and to create a vector, we have to use the C function, right? And in it, you have to pass the values, right? So pass whatever values you want to store on the vector, and let's see how it goes. So now vector is created. See here in this case, just see the global environment. In the global environment, it says, okay, it's a vector. It has 3, um, elements. Okay, 1, 2, 3. And what are the values of the element? 1, 2, and 3. Similarly, if you want to create a vector of logical elements, then in that case, TFT. So a logical vector 3, it's of type logical. 1, 2, 3, true, false, and true are the elements. So you can represent it with capital T, or you can just write down this. Next, suppose if I want to access the first element of the vector, then in that case, because this is the location 1, 2, and 3, so if I want to extract or filter the first element of this particular vector, then what I need to do is I need to just write down or use the square brackets. So vec of 1, right? Vec of 1 will extract the first element or the value, or it will print the first value of the vector, which is true in this case. So suppose if I use, let's say, vector 2, and of 1. So in this case, it should print A. Okay, I didn't create this. I'm sorry. So let's say because 1 is created. So it gives 1. So if you want to have a list of elements, you just don't want one element, you want a range of element, then in this case you need to give the starting range and the last ending range, and then it will print the range of the values. See here, vector 3 square bracket 2 colon 3. Now 2 colon 3, that means it should print second and third value. Suppose if we had 6 values, then 2 comma 6, 2 colon 6, I'm sorry. So from 2 to 6, all the values it is going to print. So it is printing false and true, which is the element in second and third, right? Now let's come to, let's see that whether this is allowed or not. Suppose if I want to create a vector with the, mixed values like A, 1, 2, and B, where A and B are, characters, and 1 and 2 are numeric value. Let's see this. So what did it do? It created it. We didn't get any error, right? So, but just check it over here. This is vector 4 variable. So what did it do? It just typecasted 1 and 2, that is the numeric value. It converted into, because vector is a homogeneous data structure, right? So it converted 1 and 2 to the character type. See this, A, 1, 2, all are of type character, and vector 4 is a character vector. Vec 4 is a character vector, right? So if we will print vec 4, we are going to get 4 character type values, right? So mixed type is not allowed, right? So in R. Now if you want to create a heterogeneous data set like this, we want that 1 and 2 should sustain like that only, and character. So if in that case, what we need to do, we have to create list. We need to create list. So list is another data structure, which is a single dimensional data structure with heterogeneous data set. So list 1, this is a variable list 1, and how do you create it? You need to use the list function, and you need to write down all the arguments which you want to store it in the list 1 variable. Let's see. When I execute it, so list 1 value is created. It consists of list of 4, and what are the values? A contains 4, the character, B contains the numeric value, C contains the numeric value, and D contains the no, just a second. Yeah, sorry. So the list was created, and when I click on that, I get the values. Here, the first one is Rajni, 1, Rajni, true, and 2. So whatever I have stored, they are stored as the elements in particular list. Now coming back to this. Now if you want to find out, suppose if I want to print the list, see I printed the list. So the same list which I was able to see on the screen, here also on the console it is printed. See, in the first row 1 is stored. In the second row the numeric value is stored, or the second element is stored. In the third row, the third row first column. See, 3 1 means third row first column. The third value is stored, and the fourth row, first column, 2 is stored, right? Now suppose if I want to find out what is the class of this, uh, but then I cannot give the class of the list 1, because it is of mixed bag type of data structure. So I have to tell that which elements class I want to find out. So here I want to find out the element, or sorry, the class type of the second element. So then I have to, in square brackets, I have to mention that which elements class I want to find. So the second one was RAJNI, as it can be seen from here. So that is the character type. So hence it gave me the character. Similarly, I can also create a multidimensional, list, right? Just go through this. Not the list of multiple types, right? So vectors of multiple types, right? So this list is a vector of multiple collection of multiple vectors, right? So how do you do it? So C creates a vector. So this is one vector. So in the first element, one vector is stored, which is of numeric type. Then in the second, in the second element, the another vector is stored, which is of character type. And then the last one, the logical uh, elements are stored, right? And logical element vector is stored. So this way also you can create a list which is a combination of various vectors. So if I run this and if I print list 2, so all the, in the see here, in the first row, first column 1, 2, 3 is stored. Second row, first column ABC is stored, and third row, first column 2 false. And so it is also possible that in a list you can store the collection of vectors. Now let's come to the matrix. All of you know what is a matrix. It's a two-dimensional matrix. In the to create a matrix, the function is matrix matrix, right? And there you are storing the vector of numeric type 1, 2, 3, 4, 5, and that you are calling it, or you're assigning it as M1, right? So the M1 is a matrix which you are creating, and when you print it, so this, see here, it's a vector, it's a matrix, 1 to 5 elements. And how many rows are there in that matrix? You have only one row, that is 1, 2, 3, 4, and 5. So if you print it, this is how it goes, that 5 rows are there and one column is there, and 1, 2, 3, 4, 5 is stored in this particular matrix. Now if you want to create rows and columns, if you want to create rows and columns, then in that case you have to specify that how many rows you need to have and how many columns you need to have, right? So if you here in this case we have two, I've specified n row means 2 rows and n columns means 4 columns, right? So a total 8 elements. So combine all the 8 elements and assign it to 2 rows and 4 columns. So another matrix is created, matrix 2, and when I print this matrix, see here, 1, 2, 3, 4. So first it goes like this. In the first column 1, 2, second column 3, 4, third column 5, 6, and four column 7, 8. But suppose if you want that the element should be divided row wise, then in that case you have to use this by row T. By row T. T means true, right? So you want it should be divided using row, not column wise. So it should go like this: 1, 2, 3, 4, 5, 6, 7, 8. So it should go row wise, not column wise. So in that case, you have to enable by row Boolean argument, right? So let's see. So it has 2 rows, 2 columns, and by row you're trying to divide it. And when we execute this M2 now, see, earlier it was 1, 2, 3, 4, 5, 6, and 7, 8. Now it is 1, 2, 3, 4, 5, 6, and 7, 8. Suppose if I want to extract an element from 1, 2. 1, 2 means first row and second column. Okay, some mistake has happened. So first row and second column. So I'll be able to extract one element. I actually missed while selecting it. I just missed the square bracket. So that is why that error came, that it is expected. So anyways, when I selected the whole, I got that. So I will be able to extract one element by mentioning the row and the column dimension of the array. So of the matrix. Now, the next type of data structure which is allowed is vector data structure. Sorry, array data structure. And in array data structure, what you can do is you can create a combination of more than one vector. So you can, let's see how it works. So this is first vector which is created. Vector is a collection of homogeneous data. We have seen that. And then vector 2 is created. And then what you're doing is you're creating an array. So now you are going for a multi-dimensional. So here matrix was a two-dimensional, you can say, data structure. If you want to go for a multi-dimensional data structure, you need to use array, right? So array data structure, you can combine as many as you want, and then you need to give the dimension of it, that how many rows should be there, how many columns should be there. See this, and when we write it, this is dim stands for dimension, right? And when we print the result, so we get it like this. In the first row, first column, uh, these elements are there: 5, 9, 3, 7, 7, 8, 9, 10, 11, 12. Okay, and in the second D, what we are having, 13, 14, 15. So we are not left with any more elements. So it will just repeat itself. 5, 9, 3 again, 7, 8, 9 till it fills all the elements. The next type of data structure, which is probably the last data structure, is factor. So wherever you want to have levels like red, blue, color, green, or you want to have that, suppose a diamond is there, then what type of diamond it is, VS1, VS2, JS, whatever. So if you want to, classify it, that, so in that case, you need to have store that data structure as factor. So how do you do it? The example is here: color, C, red, blue, green. So 3 levels are created over here, and see, color, 3 levels are created of characters type. Then you have to convert it into factor. Now, how does it happen? So that factor, when you create it, you are storing it in color1 variable. So what it will do is it will change this value red to first level. I mean, it does it alphabetically. Okay, so the one it will take as first level, second it will take. So when you want to classify the data, right, then in that case, you need to convert the character type data in the form of factors, right? So the function for it is as dot factor, and you pass the particular character data structure, and then you store it. See, it has converted it. Color one, it is of now type factor. It is of type factor with 3 levels: blue, green. See, blue, why first it came, though we have mentioned R, because it is doing it alphabetically. So blue, green, and red, right? And suppose if I print color1, then in that case it will print the levels: red, blue, green, whatever the value is, and the levels are blue, which is 1, green is assigned 2, and red is assigned 3. And the last one here is Data frames is like if you want to create a CSV file or you want to create a list, then you need to create a data frame out of it. So data frame is collection of vectors and different types of vectors or heterogeneous vectors, you can say, right? So like employee.data frame you're making. So in that case, how you need to do, you need to create a function that is data.frame, and inside it, what are the various, these are the columns. So the name of the data set is employee.dataset, or the data frame is employee.data, and these are the columns: employee underscore ID, employee underscore name, salary, start data, and you want that whatever the numeric value, sorry, the character values are there, you want to classify or convert it into the factors. Then in that case, you have to write down string as factors true. Here in this case, we want to keep them as name only. So then in this case, we need to write down string as factor false, right? So these are the various types of, columns which are created. So when I run it, so employee.data now consists of 5 objects and five each with 5 entries and with the 4 variables, right? Suppose if I click on it, so view emp.data, automatically it get executed, and this is a file which I have created. So it contains emp underscore id, emp name, salary, data. So this is a frame which I have created, which has 5 entries. So that's why 5 objects of 4 variables, 1, 2, 3, and 4. So this is the another data structure which you can create using R. Now suppose if I want to extract only the employee name, so emp data, I'll be using this dollar symbol of emp name. So I want only the name of all the employees. So in that case, I will just extract it using the dollar operator. So here you can just see Rick, Dan, Michael, Ryan, and Gary, whatever it is, that gets printed. So this is all about the data structure. The next thing which, let me see, I'm almost done with the time, though I prepared a lot of things. So next thing is the inbuilt function which can be created or which can be used in R, that is max, mean, min, range, str, head, tail, and data, right? So let me check where I have, I'll close this unnecessary. And just a second. I probably didn't select that file. Yeah, here it is. So suppose if we want to, for this, I have selected to do that all the operations. See here, all the inbuilt functions. I have selected the data set. To select the data set, I have used that data set crop underscore production. So what I need to do is first I need to uh, import the data set. So in that case, I need to write down the CSV file. I need to read down the CSV file. So here it is creating an error. So I'll just first read the CSV file. So this command. So this is the file. This is the command, that is read.csv file. So it will read the CSV file of crop underscore production, which I have kept in my working directory, which is documents currently. So if I've kept that file, it will just read it using read.csv. So then when I read it, so see crop underscore production, it is a big data set which is containing 46091 objects with 7 variables. Now suppose if I want to view it, view function is to view the, so this is what I data set I was talking about, all the states, district name, the crop year, season, then the crop, then area, and the production. So this is for all the states of India and their districts. Uh, Now suppose if I want to find out what type of data sets it is, or what are the various variables, and what are the type of it, so all the details of it I can get through the str function. Similarly, if I want to find out the first six elements or rows in the data set, then the head function I'm going to use. So it will give me the first six, 1, 2, 3, 4, 6, and that consists of Andaman and Nicobar. District name is Nicobar, and all the details of it. Suppose if I want to find out the last six, then details or rows, then in that case I'll be using the tail function. Suppose if I want to extract only the season, that means only one column of a particular you know data set, then in that case the dollar operator will be used. Crop production is the data set and it's a season. So how many seasons are there? So table will just tell me that in the season how many types of categories are there and what are its count. So autumn, kharif, rabi, summer, whole year, winter, and how many elements or entries are there, that you can get through the table. Similarly, if I want to find out the minimum in an area, then min function will be used. Crop production, then dollar symbol area, that means from this particular data set, the area column, you want to find out the minimum value. So min function would be executed. Similarly, max. Function. If you want to find the mean, then you are going to, I hope it is clear that crop production, you have to say, if you want to access one, what we say row of it, so crop production dollar, the particular column name is to be mentioned over here. So this is all about functions. So can I continue?
Yes, yes, ma'am. You can briefly summarize.
I need to briefly summarize it. Okay, I'll
Dr.
try to
Rajni, you
finish
can
it
take
up.
5 minutes more.
5 minutes is too less though.
Yeah, 5 to
Okay,
10
sir,
minutes you can take, no issue.
Okay. Thank you, sir. Thanks a lot. Actually, it's a big. It minimum it takes 2 hours to explain the whole
Yeah, yeah.
hour, which is definitely it's very difficult.
Okay,
Though I
yes.
try to keep the script. Anyways, if you want to select uh, one particular row or element, okay, and you want to find out whether the value is apply a condition to it, then in that case, if function, I'll just skip this for you because again it will take a lot of time. I just want to show the plot. So if you can do or take the decision that yes, if the crop production dollar copper year, so that means in the crop production crop year is less than 2000, then in that case you have to mention that it is the latest data set. Okay, so if is used to take or do the decision making. Similarly, if else, so that means if it is true then do this, if it is not true then do that. So if you want to have two options, then in that case if function would be used. So I'll just execute one for you. So this is actually, see here, crop year of 1, that means it is just doing with the first element. If you want to do it for all the elements in the what we say in the column, then in that case you have to initiate a loop. Okay, so if I run this, see it is now printing latest data set. So that means the first element crop year is greater than 2000, so hence it is latest data set. Similarly, for if you want to do it for all the elements, or so you need to initiate the loop and using for or while. So for one I in vector 1, if crop production the same thing, but then in this case here the loop is, so as the value of I changes, so it will be, so it is from 1 to 10. So for first 10 elements I am trying to do the same using the for loops. I'll just execute it without, so see 10, so i's value is 1 to 10, and it is executing, so which is greater than 2000. So hence three entries out of the 10 were greater, so it was hence printing latest data set. Suppose if I want to clear the terminal, this is the thing which I going to do. So while I just leave it for now, let's do the, so I'll just to motivate you that how you can, uh, plot the things. Let's see this. These are the packages which you need to download or import. So packages can be imported using the install button. See install, and whatever package you want to say reader and ggplot2, you can just write down and just press install. I have already done it, and every time you need to activate it, right? So you have to just click on it, and that gets selected. So right now, either you can do it like this, or you can just use this function called as library, and these two I am including it. Okay, this package I am including it, and then the crop production I am reading the CSV file. So I just want, see the CSV file has been read. Okay, and suppose if I want to view function I have already used, right? I want to find out how many rows are there in that particular CSV file. So these are the number of rows, these are the number of columns. Okay, and what are the various column names, so that we can be obtained from call names. Now suppose if I want to filter the data of Andhra Pradesh, okay, and I want that the crop production dollar state name is Andhra Pradesh and district name is Anantapur. So Andhra Pradesh and Anantapur's data I want, okay, and crop production year is 1997. I want all the details of it. So how will I do it? Again, I just show you. Andhra Pradesh. So I'm storing the selected data, filtered data in the Andhra Pradesh production data set. Then crop production is my data set, which is my function. In which function, what all rows I want to select? I want to select the rows who of only whose state name is Andhra Pradesh. So and is, to combine the two conditions. Production is district name is Anantapur, and the year is 1997, and comma I want all the columns. Then in that case, if I run it, so I have created the Andhra production data set with 28 rows and 7 variables, because I've selected all the variables, right? So now suppose if I want to plot, so I'll be using ggplot, Andhra Pradesh production, that is the data set which I want to pass. Aesthetics, that means what I want in the x-axis. So in the x-axis, I want the crop. In the y-axis, I want the production, right? And what type of graph I want to draw. So there are a lot of different types of box plot you want to plot, or you want to plot line, or you want to plot bar graph, whatever you want to plot, the geom underscore bar. Here in this case we are plotting this, and then you need to do its settings, right? So let's see how, or give it settings. So in the plot, it'll just take time because the data is, so here in this case, if I zoom it, this is the plot. So I just see that Kharif and Rabi has been plotted, and so these are the plants. See, wheat is not planted in Andhra Pradesh. First of all, from this we can analyze it. This is only the Kharif plant, sugarcane. This rice is throughout the season, in both the season, whereas the production in the Rabi is less comparative to the production in the Kharif season, right? So this is how you can compare or plot and do the comparison or do the analysis. One more graph I just want to show. I just execute it and then I'll explain. So this is another data structure which I've created. What is there? Andhra production, that is another data set which I have created. In this case, what condition I have applied or how I have filtered the data, which crop production, state name is Andhra Pradesh, crop production, district name is Anantapur. And here in this case, the crop I'm filtering out is rice. So I want only the details of rice, right? And then I want to plot it. So what I am doing is I am comparing rice production of Rabi and Kharif of only the rice. So here it is for all the, what we say, all the plants, right? So I just want to compare it and put it for this only. So Andhra Pradesh data set I am sending, and I want to plot a line graph, and in the x-axis Andhra Pradesh Andhra production crop year. In the x-axis I want to put, and in the y-axis I want to put the production, and the through the season. I mean, there are two types of seasons, so this season should be shown through the color. So I'll just execute it. See, this is how it goes for the rice plant. So production, crop year, and the production. So you can just analyze things from here, that yes, in 2000 somewhere, the production in the Rabi went up, and otherwise there is a throughout, it's a linear plot, right? So the cultivation of rice is always less in Rabi than comparative to the Kharif, but in 2000 it increased. So why it increased, we can analyze on it, and keeping on this factor or seeing on this factor, we can take some decision, right? So this is the last plot which I'm just showing, and then we'll just finish because of the shortage of the time. Right, suppose if I want to extract the rice production, this I've done already, just a minute. I'll just execute this line, last one. This facet underscore wrap means with respect to all the crops, if I want the same graph, right? So it is filtering the take little time. So till then I'll explain this. We have filtered the data. Andhra production we have filtered based on Andhra Pradesh. The district name is Anantapur. Okay, and in ggplot, what we are trying to plot is that we are sending this data set and we want to plot a line crop year, then the production and season, right? But facet wrap wrap. That means for all the type of crops you want it, right? So it's not visible here, but if you zoom it, see, this is for arhar, bajra, banana, for all individually. This graph has been created, so you can just make an analysis that in Andhra Pradesh, what type of crop and in which season the growth and production has been done. So this is crop year, and this is production based on each. It has been created. So this is all from my side right now. Though there are a lot of many things, but I hope it gave you a motivation and it is easy to do it, right? And trust me, even if you're not a good coder or if you have not done coding, still it is very easy to do it. But one thing is you need to download it in your system and start doing it. And there are a lot of help and tutorials available. Thank you. That's all from my side. And Chetan sir?
Yes, please stop sharing, ma'am.
I am doing that.
Thank you so much, ma'am, for this informative session. I hope that our participant gain good insights from that. Ma'am, we received a few questions from our participants, so I request you to answer those. Our first question is, how to do data entry for arranging treatments and application in R?
See, treatments and replication, you have to prepare a data set, and you have to either store it in the form of Excel or CSV, and then just input it inside the way we have done it using read CSV function. Otherwise, also there are a lot of help available. You have to explore the packages on your own and then find it out.
Okay, ma'am, thank you. And another question is, can we analyze agriculture parameters in R?
Why not? We can.
Yeah, of course. Yes, right. Okay, so I think we have covered all the questions. So again, thank you so much, ma'am. That was a really very wonderful session. Now we are moving further towards our plenary session.
Can I take 1 minute?
Yes, ma'am. Yes, sure.
Yes, yes.
One thing is, even though I prepared a lot, I couldn't cover a few things like filtering of the data using other functions. Anyways, if anyone has any query or any doubts, they can get in touch with me in this. I'm just typing my email ID for the viewers. And the second thing is, I would like to thank Dr. Chetan for giving me this opportunity, and I'm very thankful to him and his team. Thanks a lot for arranging this wonderful session. That's it. Thank you.
Okay,
Thank you,
welcome.
ma'am. Thank you. Now we are going to start our plenary session of this webinar. First, I would like to welcome the chief guest of this plenary session, Dr. Prashant Kunchadia, who is the Secretary of Vigyan Gujri at Gujarat Prant.
1 minute, 1 minute. Are you see?
Yes, sir.
Yes, Prasant sir. Okay, okay. Now you can start, Ayushi.
Okay, okay. So I welcome you, sir, Dr. Prashant Kunchadia. I also welcome Dr. R.S. Mundi, Professor and PI, Nahib Cast, Dr. C.R. Dudhagra, Organizing Secretary of this webinar, and Dr. Y.A. Lad, CCPI of this Nahib Cast project. So first, I would like to request Dr. R.S. Mundi, sir, for welcome address.
Thank you, Aishi. Thank you. Very nice and briefly. And now, once again, I welcome all of you, mainly in this plenary session. First of all, I welcome our chief guest, Dr. Prashant Kunjadia Saab, Secretary, Vigyan Gujri, Gujarat Prant. Sir, welcome you to this plenary session. Since morning, we are having some technical sessions, and they are really very important sessions, wonderful sessions, mainly for the students in higher education and faculty members. Though we had a discussion that this kind of technical sessions need some, maybe the hands-on practice is required. And maybe next time, Dr. Chetan, we would like to invite these experts again and for some hands-on training, because very, very important. Dr. Rajni Mohana, she was discussing and you are getting interested, but it needs some practice also. And that's important. So welcome you, sir. And also Dr. Rajni Mohana, who was the last speaker. I welcome you, madam, also to this plenary sessions. Our director, IT and CCPI of our this group, IT group, Dr. Kathija sir, I welcome you. And of course, our organizing secretary, Dr. Dudhatra, he is with us, and all other members, Dr. Y.A. Lad, our joint organizing secretary, other team members, all are there. My principal and dean, though he is not joining, but I had asked him, Dr. Vaishi Jhala, he has been with us. He is also seen, and he discussed with me about these all sessions also. I welcome. So once again, I welcome you all to this plenary session, and we are here to listen some observations from the organizing secretary and listen our chief guest on this technical session on data science, very, very important in agriculture. And without that, a detailed, rigorous analysis nowadays cannot be done, is not possible. So just with these few things, sir, we are here to listen you, our chief guest. Over to you, Aishi, please.
Yes, sir. Thank you, sir. I would like to thank all the speakers, Dr. Ankur Saxena ji, Meenakshi ji, and Rajni Mohana ji, Dr. Rajni Mohana ji. So this is a very important event organized by NHEP, and in the context of IISF, though it has been over, but it is very important that we are organizing a webinar on data science. for agriculture, because as a India, we know that in Indian context, we are having a lot of arable land, and we are having a lot of biodiversity in the various crops. Plus, indigenous crops are also there, and some different kind of what you can say, foreign crops are also we are cultivating nowadays. So data of all these things is very important, and with the development of computer technology and IoTs and other things, and a lot of young entrepreneur in the field
नहीं दिया इसमें कुछ बचा है
holding new kind of things, like we can design what kind of crops we require, and what kind of things are important for in Indian context, and as well as in the world context, because this data gives us idea that what exactly is going on. Earlier it was a condition that we could not uh, do certain kind of things because of lack of information, and but in the present corona pandemic condition, we have also come up with new things in the education. I think that has also reached to the house of farmers also, and that particular technology, now if we start exercising it, we can also get real time data from the field, other than what kind of experiments we are doing at research station and all. So we can also control certain things like overproduction also we can control. We can also like for if the country like India, we can also save a lot of foreign currency by stopping or designing the like crop requirement of our country. So I think this particular kind of seminar and such webinars are very important in this context, and in future we will have a lot of new kind of platforms, as well as more and more number of agriculturists which will be trained on this kind of things to ultimately to benefit the country as well as the human kind, because we know that though we are producing a lot of food, at the same time in our country number of people sleep without food, and the similar situation is there also in at the worldwide, and many of the countries are producing this kind of thing. So if we design some certain things and work at the global level, or at least not, if not possible at global level, then at least at India level we should work on it, and we should feed each and everybody, including human and other animals also, because we know that our major stack of the food is also going for the indirectly to the animals also in the their feed preparation. So this kind of data science webinar may help us in future to design first of all the capacity of particular geographic region in various you can say ways to help overall farmers output, and not only output in terms of production, but also in terms of economic benefit, because nowadays our dearest Prime Minister Modi ji is talking about the Atmanirbhar and increasing the double income of the farmers. So in that context also, it may be helpful. So ultimately, I wish all the participants best wishes, and hope that we will also come up with the new results and designs of the experiments in future in the same topic, and my best wishes to all of you. Thank you.
Thank you very much, sir, for sharing your thoughts with us. Now, I would like to request Dr. C.R. Dudagra for sharing the observation from this webinar. Over to you, sir. Sir, please unmute yourself.
Thank you, Dr. Prashant Kunjadia, sir, Secretary, Vignan Gurjari, Gujarat Prant. Thank you, sir, for sparing your valuable time with us. Now, I am
Thank you,
sharing
sir.
I am sharing some observation from the today's webinar. So, Our first speaker, Dr. Samir Rohadia sir, is there. It was the chief guest and keynote speaker from the Germany. He has explored the various concepts of big data. He explored the 3 V's concepts: volume, velocity, and variety. And second, our speaker is Dr. Ankur Saxena. He has explored how data science can be useful for the various academic and research related work, and explain also which data science applications, different data science algorithm can be implemented on the agriculture sectors. So these two sessions are from morning, these two are from morning sessions, and afternoon sessions. The first session was taken by Dr. Meenakshi Arya. He says about the tools for data science. She explore the Weka tools for data science. It is very, very useful to the students and researchers and faculties for doing various different types of analysis and visualizing. She has also explained this tool using the different examples of iris. After that, the last session was taken by Dr. Rajni Mohana. He explored the R tools for data science, how we can use the R starting from the basics, from variable declaration and to cover to the plot designings. So in this webinar, the first two session was related to the basic idea how we can use, and afternoon session are hands-on session by using the different tools. Both expert has explained how this tool can be used. So I hope that this webinar is more useful to all the participants for his study and research related work. So these are the observations from the today's webinar.
Thank you so much, sir, for sharing the observation from this webinar. Now, I request Dr. Vailad for vote of thanks. Just few seconds. He is joining soon. Just wait for a few seconds.
Okay. Our last speaker, Dr. Rajni Mohana, is here. So if you want to share something, then you can share, ma'am. Unmute yourself, ma'am. Yes, Rajni ma'am, you can unmute yourself.
Am I audible, sir?
Yes, yes.
Sir, it's though I didn't explore it, but now going through all the sessions today, I feel that a lot of work can be done in this crop in agricultural industry, and I hope that people, because now today's focus is to to enhance the crop cultivation and all those things. So if we merge the field of IoT and agriculture and data science, so we can move towards better our country can do better in terms of growth of production and of crops.
Yes, Ayushi. Okay.
Okay. Now, at the end, I myself, Dr. Yogesh, propose a vote of thanks for this wonderful webinar. We can say that whole day we have worked on so many things in a length. In this webinar, I just want to thank the Dr. Rajni Mohana, who has she has put the valuable efforts for the whole event. I think it is very interesting to hear so many things related to data science. Actually, I think agriculture university right now, there are a few works has been started in particularly in the data science. Even in this project, we are going to work so many things on the data science. Thank you very much, madam, for your wonderful lectures, as well as I want to thank the in this webinar, the topic which is chosen by the Dr. Meenakshi Arya. She has given the very wonderful insight for the topic itself. I think a few students, we got carried that they want to carry out further research in case of data science. Thank you very much, madam, for your wonderful lectures. As well as I want to thank the Dr. Prasant Kunjadia, who has given the so many insight related topic, as well as the insight about the what Vigyan Gujari doing for the Gujarat. I think thank you very much, sir, for your wonderful participants. And in the, I think in the morning session, we got very good lecture from the Dr. Ankur Saxena, who has given the deep insight about the artificial intelligence in the data science. Thank you very much, sir, for this gracing this event. And I would also like to thank the who has put their valuable efforts, I think, from last 15 days. Dr. Chetan Dubey, who is the organizing secretary for the event. Thank you very much for the choosing such a topic, as well as choosing the right speaker for the event. I would also like to thank all the members who directly indirectly joined this event, as well as the participants who has, I think it is not in the Gujarat, but they are from the other state as well as other country who has registered for this event. Thank you very much for kind participation. We are continuing to organize such event. We have one big event, that is Friday training program on the food and dairy science we are going to organize. And all are requested to register for them also. Thank you. Thank you very much, sir.
Yes, Ayushi.